Okay, students, let's discuss about EMF, voltage and internal resistance of a cell. EMF, voltage and internal resistance of a cell, for which let's have an electrolytic cell over here. This is our electrolytic cell. You could see it in the picture. And this electrolytic cell consists of two electrodes, one electron, the electrolyte, and if you are connecting it to an external resistor, there will be a current flowing through the cell. So the circuit will have a current. Then EMF of the cell. EMF of the cell, normally we used to denote it by E. EMF, the expansion of EMF is electromotive force. If you are hearing electromotive force, you might think that EMF is a force. But EMF is not actually a force. EMF is the work done to move a unit positive charge from one electrode to another electrode through the electrolyte. Let me repeat. EMF is the work done to move a unit positive charge from one electrode to another electrode through the electrolyte. Okay. Therefore, EMF is not force, EMF is work to move a unit positive charge from one electrode to another electrode through the electrolyte. And the next term that we have to learn is internal resistance. Internal resistance is denoted by the letter small r. What is internal resistance? Internal resistance is the resistance offered by the cell. Internal resistance, it is the resistance offered by the cell, or in other sense we could say it is the obstruction offered by the electrolyte of the cell when charge is flowing from one electrode to another electrode. It is the obstruction offered by electrolyte of a cell when a charge is flowing from one electrode to another electrode. Okay. Therefore, this is regarding internal resistance. Internal resistance is the obstruction offered by the electrolyte of the cell when a charge is flowing from one electrode to another electrode. EMF is the total work done in moving a unit positive charge from one electrode to another electrode through the electrolyte. We could say, or we could draw a normal electrical circuit over here. That is, you could see we are having a cell which is of EMF E and its internal resistance is small r. It is connected to an external resistance of capital R. Internal resistance, normally in some circuit diagrams, they will give that internal resistance denoted like this. But some circuit diagram, they won't be denoting this internal resistance like this. You should understand internal resistance, it is the resistance offered by this cell. Okay. Therefore, if we are having a circuit like this, capital R is the external resistance, the cell's electromotive forces, EMF is E, and its internal resistance is R. Now, this is in a closed circuit, and if it is in a closed circuit, there will be a current passing through the resistor, or there will be a current passing through the circuit. Let's say the current passing through the circuit is I. If the current passing through the circuit is I, then what is the total obstruction or the total resistance of the cell? The total resistance of the cell, it should be external resistance plus internal resistance. The total obstruction of the cell should be external resistance plus internal resistance. Okay. Then what is the relation between EMF current and resistance? The relation between EMF current and resistance is EMF is equal to current into total resistance. Current into total resistance means R plus small r. E is equal to I into R plus small r. This is the relation between EMF and current. This is the relation between EMF and current. Okay, you might have learned voltage. Voltage across the resistor. Actually speaking, voltage across the resistor is the potential difference between the two terminals of the resistor. What is voltage across a resistor? It is the potential difference between the two terminals of the resistor. By Ohm's law, we know V is equal to IR. Potential difference across the resistor should be equal to current into resistance. We have learned it from our Ohm's law. Okay, then if I am expanding this equation, I could write E is equal to IR plus I small r. Can I? Yes. Then in this, what is IR? IR is V. IR is V. Therefore, I could write E is equal to V plus IR. E is equal to V plus IR. This is the relation between EMF and voltage. This is the relation between EMF and voltage. I could even write V is equal to E minus IR. The R in this equation is small r, that is internal resistance. Okay. Therefore, this is our equation for EMF, voltage and current. Let's understand this situation with the help of a normal circuit diagram and with the help of a problem. Okay. Therefore, let's have a resistor. Let's say it is of 10 ohm. It is connected to a battery which is having an internal resistance. The EMF of this battery is 20 volt and the internal resistance, let's say it is 0.1 ohm. The EMF of this battery is 20 volt and internal resistance is 0.1 ohm. And sometimes, as I have said, sometimes they will denote internal resistance like this. Sometimes there won't be a simple like this. Okay. If there is a resistance associated with the cell, that is internal resistance. Okay. Therefore, let's have our circuit like this. We are asked to find out the current passing through the circuit, and the potential difference across the 10 ohm resistor. For saying that, let's say, what is the EMF? If they are giving you a 20 volt battery, 20 volt is not potential, it is EMF. A 20 volt battery means it is 20 volt is its EMF. Therefore, over here it is 20 volt, it is its EMF. Small r in this case, it is 0.1 ohm. Small r is 0.1 ohm. The external resistance is 10 ohm. External resistance is 10 ohm. Therefore, we could say EMF is equal to I into R plus R. EMF is equal to I into R plus R. That means I could say, let me write that equation over here, I into capital R plus small r. From which we could say I is equal to EMF divided by R plus R, that is I is equal to EMF, in this case it is 20. 20 divided by capital R plus small r, that is, let me write 10 plus 0.1, that is 10.1. Okay. That is equal to 1.98 ampere. This is the current. 1.98 ampere will be the current flowing through this circuit. Then, if we are asked to find out the potential difference across the 10 ohm resistor, it can be written by V is equal to IR. V is equal to I, it is 1.98 into external resistance, in this case it is 10. Therefore, it will be 19.8 volt. 19.8 volt, it is the potential difference across the resistor. If you are reanalyzing this whole thing, the EMF was 20 volt. The potential difference was 19.8. Is there a huge difference? No, there's only a slight difference. EMF is slightly less than voltage. EMF is slightly less than voltage. That is, there will be a potential drop across the internal resistance of the cell. That's the reason why EMF is becoming, or EMF is greater than voltage. Voltage is slightly less than EMF, and there is a potential drop across the internal resistance. That's the reason why the voltage is slightly less than EMF. കുറച്ച് പൊട്ടൻഷ്യൽ ഡ്രോപ്പ് എവിടെ സംഭവിക്കും? ഈ ഇന്റേണൽ റെസിസ്റ്റൻസിന് അക്രോസ് ആയിട്ട് സംഭവിക്കും. അതുകൊണ്ടാണ് നമുക്ക് വോൾട്ടേജ് കുറച്ച് കുറവായിട്ട് കിട്ടും, EMF-നേക്കാൾ കുറച്ച് കുറവായിട്ട് കിട്ടുന്നത്. എന്തായാലും we are getting a relation like this. And if somebody is asking you from this concept, will EMF be less than voltage? Can EMF be less than voltage? EMF ന് വോൾട്ടേജിനേക്കാൾ ചെറുതാവാൻ പറ്റും? No. എല്ലാ സമയത്തും EMF വലുതും വോൾട്ടേജ് ചെറുതുമായിരിക്കും. Can EMF be equal to voltage? Will there be a situation where EMF and voltage is equal? EMF ഉം വോൾട്ടേജും ഈക്വൽ ആവണമെങ്കിൽ ഈ ഇക്വേഷൻ, if you are looking at this equation, let's say if small r is equal to 0. If small r is equal to 0, what will happen to this equation? If small r is equal to 0, we could say small r equal to 0 ആണെങ്കിൽ EMF can be equal to voltage. That is, if we are having a cell without any internal resistance, then its EMF and voltage will be equal. Practical ആയിട്ട് പറയുമ്പം negligible internal resistance ഉള്ള സെൽ ആണെങ്കിൽ അതിന്റെ EMF തന്നെയായിരിക്കും അതിന്റെ പൊട്ടൻഷ്യൽ. Okay, പക്ഷേ in all case we cannot say EMF is equal to potential. Potential will be slightly less than EMF. Depending upon the internal resistance, the potential will change. If the internal resistance is very high, the difference between EMF and voltage will be also very high. Now you know what is EMF, voltage and internal resistance. EMF, it is the total obstruction of EMF is the work done in moving a unit positive charge from one electrode to another electrode. Internal resistance is the total obstruction offered by the electrolyte when a charge is moving from one electrode to another electrode. Voltage across a resistor is the potential difference between the two terminals of the resistor or any device. They are not equal, they are having a relation like this. You should remember this equation and this equation. These two equations are very much important, and we know V is equal to IR also. Okay.